The last handful of things we need to know about lists are two more features that they have that differ slightly from things we've seen before in Python, although we won't necessarily know it because we've done a good job of shielding some behind-the-scenes features from our users. But it's about time we learn them now. So the first thing that's actually new about Python lists for us is that these are our first example of what are called mutable objects. So primitive data types in Python, the data types we've been working with previously, integers, floats, bools, those are very fundamental and were very early advancements in computer science. They're sometimes called atomic because they can't be broken down anymore. Inside of Python, a data type like that cannot actually be changed once it's been assigned a value, and that type of object would be called immutable. Python lists are different. They are mutable. What was glossed over when we first talked about primitive data types and reassigning values to a single variable name is that that's how we interact with what's going on as the user, but it's not what's actually happening behind the scenes. So let me show you what Python is actually doing when we declare a variable name, assign a value to that variable, and then quote-unquote reassign a value later on. When we first declare our variable, let's say it's x, and we give it a value of 5. What our computer is actually doing is going to a particular spot in memory, and the computer has its own machine language for how it's going to represent this space in which to store a value. It then puts the value of 5 inside of this locker, and when we create the variable name, what we're really doing is just creating an alias for the computer for this location in memory. Let's say later on in the code, we wish to change the value that goes along with the name x from 5 to 3. What's actually going on behind the scenes is that the computer is going to a totally different locker and storing a value of 3 inside of there. And the computer is using its own internal mechanism of looking up this different locker number for it. But when we say that we want to reassign this value of 3 to the variable x, what Python does is just creates an alias for this locker by the name of x, and it will no longer point us to this locker anymore when we ask it for the value of x. It'll just point us to this locker instead. So that's the way in which primitive data types are immutable. They feel mutable from the user's end, but internally, we never changed the value of this locker. We just jumped to a different locker and updated our nickname. When we deal with Python lists, say we wanted to name a list x, maybe Python goes to this locker over here, and we store the list 1, 2, 3, 4 inside this locker. What's actually happening if we change, say, the last value in this list to something different, is that we're literally opening up this exact same locker and changing that last value. In this sense, lists are mutable because we're actually changing what's going on behind the same locker. This is a subtle distinction, but an interesting one that we'll need later on. Python lists are also what we would call dynamic, which means that they can stretch and shrink and grow to contain more or fewer values. There are several ways to stretch and shrink lists, but some of the easiest ones that we'll introduce right now is that we can actually concatenate lists, which is a method of gluing lists together, one first and then the other, via the plus function inside of Python. So because the number of months we have is not ever really something that's going to change. Let's imagine as an example that we're keeping track of miles run over the month of October. So we create a Python list object that we name October miles, and it starts out with what we've run so far. This many miles on day 1, this many miles on day 2, etc. But as the month goes on, we may run some more and want to update our list to reflect that. If over the course of the next 3 days we don't run any miles, then run 4.25 miles, and then run 17 miles, we can add to the current contents of October miles this whole list. And what will happen if we then ask to view the contents of October miles, we begin with our original list, and then this whole other list has been tacked right on to the end of our list. 0, 4 1/4, 17. So this is one way that we can add to our current list, is to add on another list to it. We can also remove elements from our list via Python's reserved word del for delete by stating the position in the original list we would like to delete. So suppose that we had erroneously entered in this 17 and we hadn't actually run 17 miles on this day, that was just a typo. We could delete it from our list by saying, let's delete the last entry in the October miles list, and then when we ask Python to print the contents of that list, you'll notice that the 17 is removed. So these are examples of one way that we can add to lists and remove items from lists, making Python lists dynamic.